I don't know how many times I'm supposed to. Hey, 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 Ethan, how's it going? Right. What are we doing? We are reading the abacus. This is an abacus. This is a counting tool. This counting tool helps me count on the abacus. Let me know if you have any questions. Why are we here? We are learning math. You are voluntarily learning math at this time. So what we're going to do is we're going to read this abacus. This abacus is a counting tool. This is my math. Math. We're doing math. So when we count, we notice we have 0. How do I know it's 0? I know it's 0 because none of the beads are touching this horizontal bar. So we have our frame. This is the frame. This is the horizontal bar. This is my counting. This is what makes us lets us know what is being counted. So as the beads touch the horizontal bar, that's what's being counted. So this is 1. When we have 2, that's what 2 looks like. And then we have 3, and then 4, and then 5. Notice that the horizontal bar is what tracks our numbers. So this is 5. The top bead will always be 5. So that's what it looks like, 5. So if I did 5, 5, 5, 5, 5, 5, those are all 5s. And then when I did 1, 1, 1, 1, 1, 1, 1, 1, these are all 1s. And then we have 2, 2, 2, 2, 2, 2, 2, and then 3, 3, 3, 3, 3, 3, 3. 4, 4, 4, 4, 4, 4, 4. They say repetition's really good, right? So then what's after 4 is 5. 5 will always be the top bead. So this is all 5. When we look, all of these beads are touching. These are 5. Hey, Monica, welcome back. So when we look, we have 5. After 5, we have 6. 6 looks very familiar. If we have this is 0. We have 1, 1, 1, 1, 1, 1, 1. And then we have 6. It just means that we're going to bring the 5 bead down. So all of this bead that comes down, that is what we call 6. So now we have 6. All of these columns have 6. And then what does 7 look like? That's what 7 looks like. It has 5, 6, 7. And it's just the same. 5, 6, 7. 5 is always going to be the top bead. 5 is the top bead, then the 2 lower beads. And then we have 8. We have 8, 5, 6, 7. No, I'm sorry. 8, 8, 8, 8, 8. These are all 8s. So when we look, every column that I have on my abacus is 8. And this is 9. Anybody have any questions? Let me know. Thank you. Hey. So we have 9. Now, what does this all mean? Every column is a digit. Every digit has numbers. Every place value. So when we look, we have our 1s. Nope, that's wrong. How do I know this is wrong? Because I have this dot indicator. This dot indicator is like a Pokemon. Do you notice that there's 2? So because there's 2, I need to choose 1. So I have to choose 1. I'm going to choose this one. So if I choose this one, then my 1s, my 10s, my 100s, my 1000s, my 10,000. When I look, I'm going to zero this out. When I zero it out, I have 1, 2, 3, 4, and then 5, 6, 7, 8, 9. And then we have 10. After 10, 1 and 0, right? Just as we write 1 and 0, if I line it up, notice there's a 0 here, and then this is a 1. And then I move it. Now we have 1 and 1. What you gonna do? 1 and 1. What you gonna do? So then we have 2. After 11 is 12. All we're doing is we're learning how to read the abacus. That's what we're doing right now. When we learn how to read the abacus, we will be able to add, subtract, multiply, and divide. Hey, Kryptonics! Welcome back. You're here for another beat up. I just like picking on you. You're just so fun. Thank you so much. Hey, Ghosty. I'm ready. I got some. Hey, you know what? I got some new sound. I don't know how old you are, but that's a very old movie. And I am dating myself because that was pretty cool. All right. We're going to go back. We're going to go back. Good morning, Ghosty. Good morning, Ghosty. That was kind of creepy. You know what? I'm not as old. Yeah, I'm pretty old. That one was I've always wanted to learn. Hey, Shannon, welcome. That movie actually came from a movie, and somebody told me that it came from Rick and Morty, but Rick and Morty actually ripped it off from Total Recall with Arnold Schwarzenegger. I don't know, like that's like a really old movie. I really love it. It sounded like Transformers. No, it wasn't Transformers. It was a guy. It was a alien. It was a guy that had a stomach. It had an alien in his stomach, and the alien in the stomach was able to do like some mind tricks or whatever. And so that's what he was doing. He was talking to Arnold Schwarzenegger, the actor, to open his mind because he wanted to talk about other things. Thank you, AI TikTok God. Alf? No, it's not Alf. Arnold Schwarzenegger. Yeah. The governor of California was an actor. It's called Total Recall. It used to have Colin Farrell with Kate Beckinsale. That's the new one. The old one was with Arnold Schwarzenegger and Shannon. Oh my gosh, I forgot her name. Shannon something. Anyways, so let's do some abacus. I'm done. Yeah, no, not Terminator. Not Terminator. Total Recall. It was after Terminator. Total Recall. Terminator was what made him big, but then afterwards he got some really big gigs. I give up. Total Recall. Total Recall. All right. So we have 0. This is what 0 looks like. That's what 0 looks like. When we look, we have 1. This is 1. And if I do all of the columns, these are all 1. And then we have 2. When I have all the columns, this is 2. And then we have 3. All of these are 3. Does that make sense? My teacher's yelling at me already. So we have 3. 1, 2, I'm sorry, 3, 3, 3, 3, 3. All of these are 3s. When they're 3s, then when after 3, there's 4. And that's what that looks like. This is what 4 looks like. And then after that, we have 5. All of these beads that are top beads, this is the value of 5. All of these are 5. This is what 5 is. So then we have 6. After 6, we have, right? This is what 6 looks like. We have 5, 6, 5, 6. This is 6, 5 on the top, 1 on the bottom. Together, they make 6. Thank you so much. So we have 7. After 7, right? We have 7. This is what 7 looks like. 5, 6, 7, 5, 6, 7. So these are all 7s. And then we have 8. That's what 8 looks like. So on the abacus, that's what 8 looks like. And then we have 9. Excuse me. So this is what 9 looks like. Okay, so you'll be wondering, like, how do we do 10? Well, that's the funny thing about it. Thank you, TikTok God, for sharing the live, making abacus cool again. Making abacus, my God, making abacus great again. So we're going to do is let's do a little review, but this time I'm only going to use the one column. We have our ones, our tens, our hundreds, our thousands, our 10,000. When we look, we have our ones, our tens, our hundreds. So when we do this, 1, 2, 3, 4, it looks very familiar, right? Just as we did before. So thank you for the follow. So we have 1, 2, 3, 4. After 4, then we have 5. After 5, we have 6, 7, 8, 9. And then after 9, this will be 10. Notice 10 is a 0 and a 1. We're going to use the columns, right? Every column is a place value. Every place value has a digit of 9. So you could do 19, and then this would be 20. 20, 30, 40, and then 50, 60, 70, 80, and then 90. Team mass following. No, I don't need team mass following. I just need to have people here that want to be here. I don't, thank you. I appreciate that. Thank you. Double tap. Thank you so much. Anna loves art. Thank you. So when we look, this is 90, 90, 9 and a 0. And then after 9, 0, we have 100. This is 100. We have 100, 200, 300, 400, and then we have 500. After 500, we have 600, 700, That's 700. 5, 6, 7, and then 800, 900, and then we have 1,000. 1,000. 1000. So let me write it out. When I write it out, it looks like this. 1, comma 000 dot 00. So now we have, it's like, yes, it is. It's like counting on your binary on your fingers. Kinda. I don't know binary. That's above my pay grade. I woke up, I'm already learning math, right? Kryptonics? I was looking at your name and I had to make sure that I got it. So, is abacus still commonly used? No. It is, you know what? It is used in the Asian countries. Hey, Shantae! Um, It is used very common in India. If you see all the YouTube videos, there's a whole bunch of YouTube kids that are Indian, and I know they're in India. It's like I think there's like a abacus school every corner, but I don't know if it's part of the school system. I know it was part of the school system in China, but I don't know if they still have it. And I know some people in Taiwan might know, but I think it's now become yeah, because I had to read it. I was going through all of my stuff, and I was like, okay, wait, it's kryptonics, and I was like, okay, I can't be calling him kryptonite. Anyways, so I know it's used in Malaysia and Singapore. Kryptonics, thank you for your patience. I appreciate that. Oh, and so is it you? I'm trying to make it more mainstream, so that's why a lot of the things I'm telling you here, it looks very familiar, right? So like we have our ones or tens or hundreds or thousands. I don't know if that made sense, but I'm trying to make it more mainstream. I'm trying to make it easier for everybody to understand. And I know that some of the videos that come out are very like they do this, but there's no actual teaching behind, how to read the abacus. And in what? In mainstream form. So there's a bunch of people that talk about how to read the abacus. I've always been mad. I think, yeah, you know what? If you let's try this out and see if you like it. I know there's a lot of people that come through my live and they mention that they have some sort of learning disability like dysgraphia or dyscalculia or ADHD or so forth. And we've been able to go through, and it's been interesting for them to see math in a different light. So let's take a look how we read the abacus, if that's okay. So what we're going to do is basically moving the beads up and down. Yes, exactly. So we're going to count. This is my horizontal bar. When I count my horizontal bar, thank you, Shannon. When I count my horizontal bar, this is 1. Every time the beads are touching this horizontal bar, this is being counted. So we have 1, 2, 3, 4. Entropy. Does that make sense? So we have 4. Abacus is the only tool that made me focus on numbers. Thank you, Ethan. So after 4, we have 5. The toppy will always be 5, right? So why am I talking about this? The reason why I want to talk about it is because it's just like using money, right? So if we use money, we have 1, this is 1. We have 2, this is 2. We have 3, right? These are pennies. These are considered 1 cent, right? This is 3, this is 3. And then we have 4, this is 4. Now, I don't know where you are in the world, but I just want to let you know that this is 1 cent. So because this is 1 cent, after 4, we have 5. The top beat is 5. I need to move this out, and I got to replace this with a nickel. This nickel is worth 5 cents. Thank you for the math in a different language because I was struggling how it was touched. Yeah. In the US, it's really, and I'm trying to make it more mainstream. I'm trying to make it more Americanized, right? North American, European, Eurocentric. I'm trying to make abacus Eurocentric. That's what it is. That's what I'm trying to do. I'm trying to make it Eurocentric. So when we add 6, how do I make 6? I make 6 with this, 5, 6. And then 7, I have 5, 6, 7, 5, 6, 7, right? It makes sense, right? Good. Thank you. We have 8. We're going to do 8, right? 5, 6, 7, 8. And then 9. Hey, good morning, Queen. Good morning, E. Good morning. This is 9. 5, 6, 7, 8, 9. This is 9. 5, 6, 7, 8, 9. So then we have 10. 10 looks like that. I don't know if I have my dime. Dime is just a dime, right? 10. That's all it is. 10. This is 10. This is 10. Because this is 10, if you notice 10, 0, and 1. So we're back again. So if I covered this up, we're at 1. We start over again. We have 1, right? But not 1. We have 0. 1, 2. We have 2. No, we don't have 2. We have 20. We have 3, right? That's what 3 looks like. But this, if I show you this, now we have 30. We have this is 40, right? 4 and a 0. Does that make sense? Right? This is 4. And then if I add the 0, now we're at 40. If I have 5, we have 5. And we add the 0, now we have 50. We have 6, and then 0, we have 60. 7, and then add the 0, now we have 70. We have 8. What we're doing is we're just learning how to read the abacus, right? We have 8. We add the 0. Now we have 80. 9, right? 9. We add the 0. We have 90. They should teach little kids this everywhere, to be honest. That's what I'm trying to do. I'm trying to make it more mainstream. And that's why I love going live, because I'm trying to make it easier for everybody to understand. I appreciate all the comments. Hello, Lisa. I appreciate all the comments, good or bad, because if you don't understand, I need to go back and I need to regroup, right? So does that make sense? We're doing place values. When we look at place values, we have our ones, our tens, our hundreds, our thousands, our 10,000s. Make sense? So when we look, right, we have our tens. Tens is what we just did. We did 90. This is 90. After 90 is 100. And it goes back again, right? 100, 200, 300, 400. Are we okay? How are we doing? Yeah? Okay. So we are learning how to read the abacus. And we're going to continue on to learn to read the abacus because I want everybody to feel comfortable how to do things. So the first thing we do, so what we did was, that's what it was doing that. All right. So we're going to continue on. Now, okay, before I forget, where is my, oh, here it is. All right. So before I forget, what we want to do is make sure that when we work with our abacus, notice that the beads have, hey, Pax. Yes, thank you. I appreciate that comment. Okay, if you notice the beads, the way the beads are, there's like a little edge. Because there's a little edge, no matter how big and chubby your fingers are, right? No matter how big and chubby your fingers are, you should be able to just move the one bead that you need. So you want to be delicate, not delicate. You want to be gentle. You want to be gentle. You don't want to be aggressive, right? You don't have to be gentle because it's made out of plastic, so it doesn't matter, right? You want to be gentle, right? When we look, we're just going to use the edge of the bead and we're just going to move it like that. So if I do 2, it looks like 2. If I do 3, that's what 3 looks like. If I do 5, it will look like that. So you can't see because, coming down here, you can't see what I'm doing with the beads. So that's why when I let you know that when I'm moving the beads, I'm just using the tips of my fingers with the tips of the edge of the bead. So we're going to be gentle with it because it's very easy to mess up your answer. So when you look, right, here is my 5. These are all 5s. If I decide to flick, the problem is if you flick too hard, some people move the beads fast and it doesn't get messed up. Yeah. And yeah, but that's because they're gentle. They're fast, but they're still gentle, right? They're not flicking too hard. So if you notice, if I flick too hard, all my numbers will get my answer will get messed up. So do not flick too hard. Thank you everybody for So again, what we're doing is we're looking at the abacus. When we look at the abacus, you want to be careful because it's very easy to move the beads. Because it's easy to move the beads, you want to use your left hand to stabilize the abacus and just use your right hand to do the calculations. Does that make sense? So what we want to do is make sure we understand that the abacus is not delicate, but it is easy to mess up. So you don't want to be aggressive and you don't want to just keep smashing it down. Because even if you smash it down, then your whole numbers will be gone. Okay, so don't need to do that. You don't need to do that. Just need to be gentle. Just to be gentle, right? And we want to be happy. When you're happy and you know it, do some abacus. All right. So what are we going to do right now? What we're going to do is we're going to read. We're going to continue to read the abacus. We're going to continue to learn to understand how to read the abacus, and we're going to go through a maze. This one is talking about 2 digits. We have 2 digits. How do I know? Because I have 1 column and 2 columns. So with this column, what number do we think that is? So if I have this number, let me see if I can, that would be the number. What number do we think that is? Please put it in the chat what number you think that is. 20. Thank you, Ethan. Thank you. Thank you. Okay, so it is 20. So I'm going to do is I'm going to follow this path, right? And what we're going to do is we're going to come here. What number is that one? Oh, that's easy. If I know what 20 is, that one and that one. Yes. What number do we think that is? Thank you. Thank you, guys. Okay, we have 21. So we're going to go here and we're over here now. Oh my God, there's a lot of easy numbers. Because we have this one and we have this one. What number do we think that is? Oh, I think entropy is gone. That's okay. 26. Ooh, getting faster. Getting faster. So then we have this one. What we're doing is we're just learning to read the abacus. So if I had this number, this is my tens, this is my ones. When I look, this is my tens, and then this is my ones. When I have 5, and then 6, and then I have 1. So in my place value, thank you, Ethan. What's my place value? I have my ones and my tens. Hey, Sil boy. Thank you, Pax. Yes, it is 61. It is 61. So now we go over here. And what number do we think this is? So when we look, we have our tens and our ones. We have our tens and our ones. And we have 1, 2, 3. Every time the beads are touching the horizontal bar, that's being counted. So we have 3. Yes, thank you. And then we have 6. How do I know? All the top bead is a value of 5, and all the bottom bead is a value of 1. So we have 36. This is 6. 30, because this is a tens, and then this is the ones. So that is 36. So we're going to go over here, and this one should be easy. What number do we think that is? That number is this one and that one. So because we have our ones and our tens, thank you, Ethan, it is 99. How do I know? 5, 6, 7, 8, 9. 5, 6, 7, 8, 9. Yep, easy, right? So we're going to go down and then we come up here. And again, we have 9. We have our 5, 6, 7, 8, 9. And then we have 1 over here. What number do we think this is? The last 2 always the decimal places? You know, that's a very good question. In this one, thank you, Pax. In this one, I choose, if you notice, there's these dot indicators. These dot indicators tell me that this is the ones. Because this is the ones, I need to choose one of them. So just like a Pokemon, I choose this one. So that's why you have 2 decimal places. However, if you choose this one, then you're shifting your place values. So you're shifting from ones over here. So instead of having it here, you're moving it here. So it'll be my ones, my tens, and my hundreds. But notice I don't have any more columns for hundreds. So that's why I don't choose this one. I choose this one. So when we look, we're moving it like that. So we have our ones, our tens. So does that make sense? And then after the ones, what sits between is our decimal. In the decimal, then we have our tenths. It's different if we have a bigger abacus. This one is a 13 column abacus. This 13 column abacus has multiple dot indicators. So there's this one, this one, this one, this one, this one. Notice that. So then does that make sense? So now we can actually choose our ones over here. When we look, thank you. When we look, every dot is a group separator. Ones, thousands, millions, billions, and trillions. Okay. Wow. All right. Hey, Uncle Patrick. That is 67. Hey, Antonio. Am I a teacher? For today. For right now, I am. I do teach abacus. And I do have classes. I do have online classes. Wow, now I know what. I'm sorry. Now I kind of want to get an abacus. That's great. I hope so. I hope you get an abacus because it's the greatest thing next to sliced bread. Thank you, eggplant. It is 58. How do I know? 5, 5, 5, 6, 7, 8. All the top bead is the value of 5. We have to remember when we do our decimal, our place values, right? We have 5 here, so that's 50, and then 5. I'm sorry, 8. 5 is 50, and then 8. 5, 6, 7, 8. So we come down here, and what number do we think this is? So if I did that, we have this, and then we have that. So the interesting thing about the abacus is mistyped, no worries. The interesting thing about the abacus is it does provide your skill to attention to detail, right? Can you get to the point where you can, but it's a lot of practice, right? It's just like playing the piano. When you play the piano, do you need to look at your keys? I'm sorry, look at your fingers? So it's kind of the same, right? Or driving a car, riding a bike, playing the piano. You know what? Typing on the keyboard. I still look at my keyboard. So it just depends on how far you want to go. Yes, 26. It is 26. So we have this one. Does that make sense, Shelly? So it's about practice. And if you really choose to go, doing it in your head. But it's like either playing the piano or it's like, typing on the keyboard. Yeah. There's a lot of people that ask about it. But like, I still write out like, checklists. And so I don't feel like it's needed to be in your head. I'm just in the abacus world, we're just trying to fill the gaps of math because I feel like abacus is the gateway to complex math. Because after you learn the math abacus method, you can go into algebra, you can go into calculus and geometry and so forth. So it lays the foundation for math. That's what it does. Yes, 54. 50, this is 5, and then this is 4. 1, 2, 3, 4. Well done. Well done. So we're on our last number. That's our last number. Oh, my face is in the way. There we go. My last number. What is my last number? Thank you. Oh, I'm sorry. Sorry, Michaela. This is what I wanted. Over here. Sorry. That was my fault. Over here. So we're looking at the maze. So when we look at the maze, that's what I was doing. I forgot to change my abacus. I started watching her videos. I'm seriously considering buying an abacus and learning more. That's fantastic, Isabel. Snicker. Thank you. Thank you, Michaela. Okay. So what we just did is we learned how to read the abacus. Let's do a little review because Snicker. I don't know if Snicker's still here. Are you still here? If you're still here, we're going to do it. If you're not here, then I'm going to move on. Yeah, let me know. But that's a funny name. All right. Okay, while I wait for Snicker to comment or not comment, I'm going to continue on. So what this is a reverse maze. What the reverse maze is that I give you a path and I wanted to, look at the number and then you're supposed to color in the dot. Does that make sense? So this is what I call a reverse maze. So you get a sample of all of the abacus, and what you're doing is you're going to look at the number here and then you're going to color it in. So this is 96, so all you got to do is 96. And then if you have here, this is 29, you just have to color in the beads that says 29. So here is a blank abacus. You have the number 17, and you go here, and so you would color in the beads. So this is what I call a reverse maze. Right. So that's what this is. And that's what my book. This is the abacus mazes. And what we're doing is only this book is doing 2 digits. I'm going to have a few more digits. We're going to do 3-digit, 4-digit, and 5-digit with the decimal. It doesn't make sense. Red Limp. Did you just come into this live into the middle of my conversation? And that was kind of rude. Maybe. That's kind of rude. You come into a conversation. Maybe you could say, like, instead of saying it doesn't make sense, maybe you should say, like, hey, I just came in. Can you do a review for me, please? Be a little bit nice. Just saying. Can you explain how it works with the decimal? Oh, thank you, Shelley. So it works exactly the same. So we have our 1, 2, 3, 4. No, that's fine. It doesn't make sense, but it's more like, hey, I just came in. Can you review? That's all I'm asking. Okay, so we're going to count it. And so after I count, Shelley, we'll go into the decimals. And it'll be easy. It's so easy. So red limp, does that make sense? This is 4. 1, 2, 3, 4. And then the top bead will always be 5. Because the top bead is 5, right? Then we can start adding 6. So we have 5 and then 6. We have 7, 8, and then 9. Those colored beads, not numbers. They're not numbers. You're absolutely right. Hey, balls on budget. If you don't know how to count stones, right. Yeah. If you don't know how to count items like this, then you don't know. Block them. It's fine. Okay. Oh, so decimals. So when we look at decimals, let's continue on. I'm not gonna. You should be. I would be cool to learn when I was younger. Yeah, you know what? I don't think we've ever learned this when I was younger. This is something that I learned when I was older. Like, and then what we're doing is, and now what I'm trying to do is I'm trying to teach all my boys. I have 3 boys, and they all know how to use the abacus. So Shelley, with their decimal, excuse me. Oh, red limp. You need to. And this is exactly why I have that one. Okay, Shelley. So we're back. This is 9, right? Our decimal sits between. Right? Our decimal sits between our 1s and our 10s. So when we look, we have 1. That's all we're doing. That's what the decimal is. So when we do 2, right? This is 2. And then we have 3, 4. So it'll be 9 0.40. And then what we have is what? We have 5. 9.5. Does that make sense, Shelly? So the decimals doesn't matter. It's just a placeholder. It's just a thing, right? Just like our commas over here. If I did 5, like 5,000, 009, so 5,009 decimal 54, if that makes sense. So 0.54. I don't know if Shelly's still here. Does that make sense, Shelly? You like that, Anna? I got jokes. I got jokes. All right. So how are we doing? Yeah. It's like so. Okay. Let's take it one step further. Let's take it one step, right? So let's say I did over here. It'd be the same thing. The only thing is now I'm stuck. I don't have the hundreds. So if I choose this, right? If I choose right? If I choose this one, this will be my ones. 1, 2, 3, 4, and then my decimal sits here. But then, no, I don't have enough beads. So, but then, if I did that, right, my decimal would be 5, 5.55555. That's what it would look like. Does that make sense? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah? Shelly, is that okay? That makes sense? So now, because I choose this one, right, I can have more decimals. But if I choose this one, then I'd have to shift everything over, and then I have bigger numbers. Yep. Easy, right? Easy. Okay. So, anybody have any questions? Other than how do I use the abacus? Right? Yeah. This dot is the only thing, is just a label. That's all it is. It's just a label. So if I did this one, right? If I just did this, I have my ones, my thousands, my millions, my billions, and my trillions. So here, this is 5. These are all 5s. And notice they're all the same color. Color has nothing to do with it. It just matters about the positioning of the beads. Okay, so because the beads are touching this horizontal bar, all of these beads are being counted. Now remember, don't flick too hard. So if I do that, I don't want to mess up my answer. So don't flick too hard. All right, so we're back to here. Now AJ, I don't know if AJ is still around, but let's do a real review. We're going to do 1, 2, I love the audio so much. Is every abacus like a, but no, it's not a base 5 because you go to 10, right? It's actually base 10. Okay, good. So what we're going to do is we're going to do 2. So these are all 2s. If I did this, this is 2. 2, 2, 2, 2, 2. What? This is 3, right? We're adding the numbers 3. So look, if you see the numbers, right? These are all the beads. These are 3. 1, 2, 3, 1, 2, 3. These are, we're just doing is we're counting the items. So when I did this, this is all 4s. These are all 4s. And then when we have it, this is all 5s. When the beads are touching the horizontal bar, these are all 5s. Because this is 5, right? Then if we add the bottom bead, which is 1, 5 plus 1 is 6. And then 5 plus 2 is 7. Do you see how that gets decomposed? So what we're doing is we understand 5, 6, 7, right? And it gets and decomposing is a kindergarten skill. So we have 7, 5, 6, 7, and then we have 8, 5, 6, 7, 8, right? Does that make sense, AJ? And then we have 9, 5, 6, 7, 8, 9. Make sense? How are we doing? So now when we look, I did this one. So if I did this, this is 9. Well, no. Well, what? You've done 9. What happens to 10? 10. Okay, let's look at 10. Let's look at 10. If you notice, 10 is 1. Ah, thank you for the heart me. 10 looks like that. 1. right? If I did that, right, 1. But then 10 is the next column. Oh, that's not right. There, 10. 0. So if I do 20 and then add the second column, that's 20. If I do 3, I add the second column, it's 30. If I add 4 and I have the second column, it's 40. Yes, good, Pax, good, right? So what we're doing is we're using the abacus to help us our place values, just like how we write. It's exactly how we write. There's nothing special about it. We're just looking at it and seeing the numbers. And that's the crazy thing about it. Like, it's amazing to see when we go from symbols, these are symbols, to the physical thing. So when we look, we have 12. When we have 12, we have 1 and we have 2. Okay, so we're done reading. Does that make sense? We're okay with reading. Now what we're going to do is we're going to start doing some adding and subtraction. Are we okay? Are we ready for adding and subtracting? When we add and subtract, we need to understand how to move the beads. When we understand, yeah, right. This is the way. I'm ready. Okay, good. So what we're going to do is we're going to understand how to move the beads. So we've done is we did some bead recognition. We had some people that come in and we're like, that I don't understand. That's fine. That's fine. So what we're going to do is we're going to do some adding and subtracting. Okay, now in the abacus world, what we're going to do is we're going to focus in on an add-in. An add-in is the thing that adds to it. So it's like abacus is life, right? What we want to do is we want to know the journey. We want to know, we don't want to go to the destination. They say, life is a marathon, not a sprint. It's all about the journey to get there, right? It's all about not the destination, but how do you get there, right? So the question is what we want to do is we want to focus in what are we adding? And my question is 5. If I have 5 on the abacus, my number is 1. Can I add 1? Can we do it? Yes, we can. So we're going to add the 1. So my final answer is 6. I'm not going to say, how do you make a 6? I'm going to be like, what can we do to add the 1? Can we add the 1? That's the question we need to ask. Can we add it? Can we do it? So if I have 7, right? This is 7, 5, 6, 7. If I have 7, do I have 1? Yes, I have a 1. I have enough beads to add the 1. I'm going to add it. So we're going to continue on. Thank you, Pax, for the heart me. So we have 5. Again, look at it. If we're looking at it, we're only focusing on the add-in. We're looking how to move the beads. I think so. I love the think so at the end. Yeah. So when I have 5, I have 5. And then I want to add the 2. Can I add the 2? Yes, we can. So we can add the 2. So my final answer is 7. Does that make sense? So what we're doing is we're learning how to move the beads. And if you know how to add, you'll know how to subtract. So we add to the horizontal bar. Now when we subtract, we move it away from the horizontal bar. So I have 2. We minus the 2. Ah, I see what you're saying, balls. Okay, so we have 3. When we have 3, right, we have 5, and then we add 3. Can we add the 3? Yes, we can, right? So my final answer is 8. I'm not going to say, how do you make an 8? I'm going to be like, can you add the 3? And we're changing the mindset. Because in elementary school, we're always focusing on the result. We're always focusing on the answer. But in abacus world, we focus on the add-in. We focus on the thing that we're using, right? And then it changes. I don't know when it changes, but then it changes. And then we go back to understanding how to add it, which I don't understand why we focus on the result in the first place. It should have never been that way. So when we have the 5, I add 5, and then I want to add 4. I'm just going to add the 4. That's all the beads at the end, 4. So my final answer is 9. So again, when we know how to add, we will know how to subtract. And that was another thing in mainstream math, is that they teach you a different way to subtracting. Whereas in abacus, if you know how to add, you will know how to subtract. You add it to the horizontal bar, you subtract it away from the horizontal bar. How are we doing? Are we okay? Does that make sense? AJ, Michaela, Entropy. I don't know if you guys are still around. Does that make sense? I'm not following. Yes. Great. Oh, yeah, eggplant's still here. Good. Right? So what we're doing is we're adding. Carly, you're going to have to wait a little bit. So the blue bead is always 5. Yes, the blue bead is always 5. This helps with mental math. I love that. Yes. Thank you for the follow, Carly. So this is a value of 5. All the blue beads is a value of 5. When I do this, this is now 6. How do I know that that's 6? Because this is 5, this is 1. All the top bead, all this bead, that's value of 1. So all of this is 1. Then we have 2, we have 3, and then we have 4. Are we okay? Does that make sense? So when we have 5, it's all like that. 5, 6, 7, 8, and then 9. That's it. That's it. Okay, so we're going to continue on. When we add, we subtract. So we know how to add. So if I have 9, I have 9, and I take away 4, I will take away the 4, right? Do I have enough beads to take away 4? Yes, I do. And my final answer is 5. And then this one is plus 4 again. So then that's 9. Okay. Again, what we're doing is we're focusing on the added. When we focus on the add-in, like this one, right? We have 3. We have 3. And then my add-in is 5. Do I have enough beads to add the 5? Yes, we do. We have enough beads to add the 5. So I'm going to add the 5. So my final answer is 8. I'm not going to focus on the result. I need to understand, how do I make an 8? No. Not how do we make an 8. Can I add a 5? So we have to switch the terminology, right? We have to switch a little bit. We have to switch the question. Can I add the 5? Not how do I make an 8? Because I'm not going to know when I have like a bunch of numbers. I'm not going to know what the answers are. What I'm going to know is, can I add it? Can I do it? I'm going to go, oh, hey, Sarah, not a problem. Thanks for stopping by. So we have 6. If I have 1, how do I make 6? 6 is a 5 and a 6, and I bring it together like that. So that was 6. So you notice, if I want to minus the 6, I take it away. Add the 6, take it away the 6. Add the 6, take it away the 6. Oh, what are we using? We're using this book. So when I have 6, my final answer is 7. So if I have 2 and I want to add the 6, right? Does that make sense? So what we're doing is we're doing a number pattern. You'll see the number pattern when it comes through. So we add the 6, take away the 6. It's the same thing with the 7. We add the 7, we take away the 7. 5, 6, 7. Add the 7, take away the 7, right? We add the 7, take away the 7. It's the same thing with the 8. So if I have 8, 5, 6, 7, 8, we add the 8. We want to take away the 8, we add the 8. And that's what this book is. So that's the last part of this book, is understanding how to take away the 5, right? How to take away our numbers. So this is minusing the 5. Why are you using that column? Oh, that's a very good question, Teach. Harmony. The reason why is because I have this thing. This is my ones indicator. If you notice, I have another label. It's a label. And this label, you just need to choose one. You just need to choose one label. So it just depends on where you want to put your place value. So you could do your ones here, or you can choose your ones here. So you could go all the way over here. I suggest you use a decimal, not a decimal. I suggest you use this indicator, any of the indicators to use as your ones column, because that will be your anchor. So it's like an anchor chart. I think that's what right? It's an anchor. So this is my ones, tens, and notice I don't have any more more columns for the hundreds. So when I look, I would probably have a lot of decimals. But if my number is bigger, then I would use this one as my anchor to be my ones. So ones, tens, hundred, thousands, 10,000. And then I have my decimals, right? Whatever sits between my ones and my tenths is my decimal. So we have my ones, my tenths, because my decimal sits between. It doesn't sit on a place value. It happens in between. So my tenths and hundreds. If I chose this one, then I'd have a lot more decimals. Does that make sense? Teach? Does that make sense, Teach? So we're done with that. We're going to do -6. We did -6. Yes, not a problem. Let me know if you have any more questions. Those are really good questions. We have 9. and we take away 8. 5, 6, 7, 8. But I'm going to be a big person. I'm going to do 8, and I do it like that. That's it, right? So we have add the 8 minus the 8. Add the 8 minus the 8. Okay, what's another question? We're done. We're done with adding. No, we're not done with adding. You know why? Because what happens when there's not enough beads? What happens when there's not enough beads? Well, what happens is we teach the children how to make a 5. Tell me, it's a very interesting question. Why are we teaching the kids how to make a 5? That's my question. I know why we do it in abacus world, just saying. I know why in the abacus world we need to teach it, but I'm not sure why mainstream math teaches it. Do you guys know why? I was about to ask negatives. You know what? We don't do negatives in abacus world because you can't take away from an object, right? So if I have 4, I can't take away 5. You can't do negatives. We have 5 fingers. Is that why? I don't know. Maybe it's because we have 5 fingers. It's easy, right? I'm not sure. But what we're going to do is we're going to power up. We're going to power up this concept. That's why we're going to do it. Whoa. It is a guess. You know, I was thinking about that. It could be because we have 5 fingers, 5 toes. Maybe that's what it is, right? Somebody said it's because it's half of 10. And I'm like, I don't know about that one. Anyways, I'm going to tell you why we in the abacus world do it. What was the question? Why are we teaching children how to make a 5? That's the question. Why are we teaching the children how to make a 5? Yeah, I don't know. I don't know why we do some of the things in mainstream math. And that's the question. Why do we do it? I know in abacus world why we do it. So here's the question. Here's my question. My question is 3. If I show you 3 on my abacus, my question is can I add 4? Can I add 4? No, I can't. I cannot add the 4. But you know, I do have materials to add a 4, right? So this is my 1. I can only have 1. But look, I have this 5 that I can utilize. I have the 5 to utilize. So if I have that 5 to utilize for the follow, what are we going to do? We're going to power up our abacus. No, power up our addition sentence. So what we're going to do is we're going to isolate this variable. Now what we're doing is a little bit about algebra. So what we're doing is we're going to isolate the variable. We're going to take this 4, and this 4, and we're going to try to substitute it. So we're doing a little bit of algebra, right? So what's going to happen is when we isolate the variable, there's my 4, I'm going to do 5, and I move this 1 to the other side, right? Why? Because I want to balance the equation. 5 minus 1 is equal to 4, right? So now what we're going to do is we're going to substitute it. So we're going to substitute 4, we're going to add the 5, and we're going to take away the 1. And my final answer is 7. So here is another question. I have 4. Because I have 4, I want to add another 4. To add another 4, I can't do it. There's not enough beads to add the 4. So what do? I substitute 5 plus the 5 minus the 1. So I substituted 5 and then take away 1. So my final answer is 8. Normally I can answer why humans do what they do, but I can't think of the logical reason why. Yeah. You know what? Logically, in abacus world, I know why we teach 5, but in mainstream math, I don't know why we teach 5. You know what I mean? It's interesting. Does that make sense? Let's do it again. But you know what? Let's use the money again. Now, if I have money, right? Money. So if I have 3, I'm going to do 3. If I have 3, and what's going to happen? I want to add 4. To add the 4, I'm doing 3. To add the 4, what are we going to do? I don't have enough beads. I only have a nickel. I only have 5 cents. I'm going to give you the 5 cents, but that's too much. So I need to take away 1 back. So my final answer is 7. I'm going to give you my nickel. I'm going to give you my 5 cents, and I take away the 1, and my final answer is 7. Roughly what age is the last question appropriate for? Preschool, kindergarten. 6, not 6, because it's 3 plus 4. Not 6, 3 plus 4. 3, I had 3, and then I'm adding the 4. And it's 7. Oh! The age group is around 3. Yeah. Well, yeah. Well, I know kindergartners. My son, when he started, I think kindergarten, so 5, 6, 7. And yeah, probably about 5, 6, 7. Like kindergarten. I know I'm trying to start them a little bit younger, but because I start them younger, they're just doing some number recognition. If they started learning their numbers at 3, they can start doing this at the age of 4, if that makes sense. This is extremely basic math, especially for kids learning abacus. Yeah. And it's interesting to see that they're able to do it. I'm ready for a quick quiz. Marvin! What are we doing? Oh, yeah. Yeah, not a problem. What are you teaching? Teach in Harmony? Are you teaching kindergartners or preschool, or what you teaching? Or are you tutoring? It's easier for the kids because they get the physical aspect and the mental aspect. Yes, these are great. Thank you so much. Kids love using their hands. Oh, high school choir director. I know there's a few students in my lives that do appreciate seeing math in a different light, and they are older. There's a few kids that actually watch me during their school time, and they show my lives to the teacher. So, I mean, for the older kids, I could see it as a remedial thing, like an intervention. For the older kids, I could see that. But usually the kids that start, I have a very young child. That's why I'm asking. How young is your child? So it all depends. Like, me talking to you guys like this. But what I would tell the kids, right? I would tell the kids just to know their formula. That's what I would do. But if it's okay me asking, how old is your child? Because it depends on. So like I have like workbooks to go with it. Like depending on how young, right? This is where I started here, and I wanted to get the kids young because we don't have enough abacus driven preschool activities. And so this one was trying to be more preschool like, where they do some number recognition. This is one, they write the number 1, this is the one on the abacus. And so I kind of like it because I also have like some cutting and pasting. This is like what number is bigger, what number is smaller. This is the puzzle where you answer the question and you find the number, and then it helps them with their motor skills to cutting and pasting, right? I have a few of those. This one is colored by number, and then this one is a pixel art. So this one is pixel art. So I didn't want to restrict them on the color that they wanted. So you choose the color, but then here is the number recognition. You find the number 6 and you find the 6, and then you figure out what the pixel art is. So that's what this is. And then you go to the next one, which is this one. So and that's what I was doing, is after we learn how to do this, right? After we learn how to move the beads, then we go into understanding how to, and this is the natural progression. So after the preschool, then you start going into how to make a 5. After you learn how to make a 5, you will learn how to minus a 5, right? That's the way I have it. So after we minus the 5, after you add the 5, you minus the 5. Yeah? If that's okay. So what are we doing? We are still, okay, cool. Thank you. I appreciate that. It's either there in my TikTok store, or you can find me. You can find me where? Where is my paper? I don't have my papers. So they are, oh, here it is. You can find me there in my TikTok store, or you can find me here. Yeah. Can you do algebra with abacus? You can start algebraic concepts with the abacus, and that's what we're doing. So this is the algebraic concept. We isolate the variable and then we subtract it, but you don't do algebra because algebra is about variables, right? It's about isolating variables. We do the concepts of algebra, but we don't do algebra, if that makes sense. This is basically adding, subtracting, multiplication, and division. That's all we're doing. You can do decimals and you can do fractions because fractions is another form of division. So we can do those, if that makes sense. But that's a good question. It's always a question. Can you do more? It's like, no, you can't do more. Because how do you, yeah, you can't, I haven't tried to figure out how to do more with an abacus because I think it's just the gateway to more complex math. Okay. So we have that, we have this, and we have that. So we have adding. What we're doing is we're adding. Okay, how are we doing? Did that make sense? So we could do it again with the 2. When we add the 2, there's not enough beats to add the 2. What are we going to do? Well, we know that what we can do is we can use our formula. Thank you, Tracy. Thank you for the rose. We can use our formula. 4 is equal to 5 minus 1. This is directions. So if I only have 2 on my abacus, I have 4, but I only have 1 nickel. I only have 5 cents. I'm going to give you the 5 cents. Oh, sorry, I need my 2. Right? But I gave you too much. I need to take away 1. So my final answer is 6. That's what we're doing. So what we're doing is we essentially does that make sense? How are we doing? After we do adding in the 5, we can do a subtracting of the 5. We okay? Does that make sense? Herman. Okay, so we're going to continue on. So we do 3. We can do 3, right? We're going to continue on with our add-ins. So when we do add-ins, we focus on the number. We don't focus on the result. We're focusing on the add-in. So when we look at it, we have 3. My formula, my addition question is 3 plus 2 is equal to 5. This is what we're teaching the kids. And then what we're going to do is we're going to power it up. When we power it up, we're going to isolate our 3. We're going to isolate our number. We're going to isolate our 3. Right? Equal to 5. Because it's equal to 5, this is not balanced. We need to balance the equation. To balance the equation, we need to minus the 2. So now what we could do is we can substitute. So my question is, I have 4. When I want to add the 3, there's not enough beats to add the 3. So what do? I need to plus the 5 minus the 2. I'm going to plus the 5 and I'm going to take away the 2. And my final answer is 7. How's that? That's all right? Does that make sense? So we can do it again. We have 3. If I have 3 on my abacus, let me use money now. So if I have 3 on my abacus, I have 3 pennies, right? But because I only have 3 pennies, right? I have 3 pennies. Whoa. And I'm going to give you 3. But look, the problem is I only have 1 nickel. Because I only have 1 nickel, which is 5 cents, I only have 5 cents. If I give you 3, if I give you my 5 cents, I need to take my change back. So I need to take away these 2. So my final answer is 6. So if I add my nickel, that's too much. I need to take away 2. So my final answer is 6. Can you do minus 2 minus 3 instead? Yes, let's do that. So why would we do that? We would do that when we do 2. So the problem with the 2 is there's not a lot of questions to do 2. You can only do a 3 or you can do a 4. So the question is, if I have 4 and I want to add the 2, when I add the 2, what do? I want to isolate the 2, right? I have 2. To isolate the 2, it's 5 minus 3. I have my nickel. I'm going to give you my nickel. I'm sorry, 4. I'm going to give you my nickel. My nickel is too much. If my nickel is too much, I'm going to give it to you. But I need to minus a 3. 1, 2. So my final answer is 6. I give you my nickel, and I take away 3. Does that make sense, Marvin? Donut Destroyer Pikachu. Yes, we could do. So we do 10 plus another 10 is 20. That's it. Do you get the same answer either way? No, you don't. You do not get the same answer because this is 6. If we did 4 plus 3, it'd be 7, right? So if I did that, it'd be 3 is equal to 5 minus 2. If the question is 4 minus 2, right? Or 4 minus 3. Does that make sense? So it all depends on this thing right here. It's very similar, but not. It's a very subtle difference between the two. Yeah? All right. How are we doing? No, yeah, go ahead. Why use this style of abacus instead of the horizontal? The horizontal? Like that? Why? Do you have one? Is that why you're asking? Because you can modify it. You can do... How do you know which one to subtract? It is the add-in. This pair, you have to memorize the pair. Hold on, teach. I'm with you. I'm just gonna find my... It's always the pair. Be careful of the pair. I'm trying to find my... That's the pair. Right, Marvin? Okay. Does that make sense, Marvin? Okay. So, teach. I don't have those kind of abacus. Yeah, I know. Yes. So I gotta set it up. So if I have 1, 2, 3, 4, 5. So it goes like this, right? Oh, here's another one. I had another one. Did I have another one? There it is. How would you use it? I actually don't know how to use the horizontal ones. I don't know how they figure place values because we don't look like this, right? We don't go horizontal. How do you know which one is 10? You don't. So what I would do is I would flip it. I would flip it. That's what I would do. So it goes horizontal. So then I would flip it like that. So we can use it as place values. And then I would just choose any one, right? That's what I would do. So when we look, right? This is modifying. I'm sorry. Let me take it back. So the Doug and Melissa one, the abacus one, right? All it is just counting one and one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you count it again for the 20s. But the problem is the human eye or mind cannot see more than 5 subjects, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 10. And if I move everything over, it would be 20. Makes sense. I bought the... Oh, I see. Okay. So Okay, good. That's very helpful. No. So what I would do is I would flip it, right? And what I would do is I you don't need to buy another abacus. I would just use what you have, but you would just have to tape tape 5 items together. So this would be your 5. Does that make sense? So I would tape it, right? And then what I'd do is I'd flip it, and after you flip it, you would have 5 left over. You would ignore the bottom ones. You would ignore these bottom ones, and you'd use it exactly the same as a soroban, because it would look like that. So it'd be so then I'd have a piece of string. I need string. I don't have string. I I don't have string. I'm going to use my mouse. So I'd have a string. Whoa, sorry, sorry, that was my fault. So I'd use a string. So if the top bead touches the string, it gets counted. If it doesn't touch the string, it would not be counted. So then I would add the 1, 2, 3, 4, or 9. Does that make sense? So now it'd be 5, 6, 7, 8, 9. I would modify it. Yeah, I would modify it. You don't need to buy another abacus. You already have that one. And it's actually kind of nice because you can see that this is a group of 5. But I would tape it just so then you would have that remembering, and then you would have it as have the thing. That's what I would do. That's what I would do. I wouldn't buy a new abacus unless you wanted to get into something bigger. And then, because you have so many columns, just choose one column. I would suggest to have 2 columns as your decimal, like money, and then you use the other 2. Then you would start here, because then you would have money, because then you could do $1, right? $1.10, $1.20, 30 cents, 40 cents, and then 50 cents. So I would leave 2 of them, and I would label one of them as your ones column. That's what I would do. Cool. Yeah, that's a good question. Let me know if you have any more questions. And we'll workshop it. But it works but the way I have it, the way it's modified, that's what I would do. I wouldn't keep it this way because we don't read our numbers, right? We don't read our numbers like this. I don't know why they did it like that, but we don't read our numbers like this, right? 6, 7, 5, 8, 1. We don't do that, right? 5, 6, 7, 8, and then 1, right? It would make sense when it's like this. Cool? Cool. That's a good question. It's been a while since I've had somebody that bought an abacus with 10 beads. There is another person. Oh my God, that's right. Somebody actually bought something from Target, and they had a 11th one. And I'm like, what? What is 11? Anyways, that's the Target abacus. And yeah. So there's things you could do to modify it. But that's what I'm saying, right? Like, in abacus world, we're given ideas, and we try to figure out how to modify it. We try to figure out how to make it work for us. And that's what this is. So, Marvin, did that make sense? When we look, we want to make sure that 2 and 3 make a 5. Are you using the 2 or are you using the 3? That's the question, right? So, what we're looking for is, are you using the 2 or are you using the 3? Then you know if you're going to add or subtract the 5. How do you know what to use? It's the question. We're looking here. You need to use this one. What is the partner of 2? The partner of 2 is 3. So I'm going to take away the 3. That's how I know. If I have the 5, right? That's how I know. Does that make sense? You're going to always add the 5, or you're going to always take away the 5. So when we look, if I do 2 equals to 5, is that balanced? Always use the bottom number. always use, it's always the number that goes into it. I see what you're saying. Yes, it is kind of the bottom, but when you get into bigger numbers, when you get into numbers like this, right? No, let's see. Okay, you know what? Hold on just a minute. I drank too much water. Hold, please. Oh my gosh. I'm so sorry. Hold, please. Okay. Okay. Let me try to find a question. Where is... Okay. Here. When we have the number here, right? We want to add the 5. We add the 5. My next number, that number, right? It's not always the bottom number. It's the number that we're adding to. So can I add a 2 here? Can I add a 2? No, I can't add a 2. How do I add a 2? Excuse me, how do I add a 2? To add the 2, I can use the 5. But if I can use the 5, this is too much. They cannot equal. I cannot substitute this. I have to subtract 3 to substitute. Does that make sense? So I'm going to add the 5. Oh no, I can add the 2 here. Sorry. Can I add the 2? Yes, I can add the 2. That's the wrong one. How about I do, what am I doing? I gotta find another one. Oh, here, maybe I'll find it over here. Add the 2. Oh. No, I'm trying to find a number for you. Oh, here. Here, I have 4. Okay, if I have 4, I want to add 2. Do I have enough beads to add the 2? But, I have another 2 here. But we want to focus on the first 2. If I want to focus on the first 2, what do? I need to substitute. 5 minus 3. Add the 5, take away the 3. And then I add the 2 again. Then I can add the 2 again. And my final answer is 8. Did that make sense, Marvin? How are we doing? So what we're doing is we're understanding how to utilize. And I like, it's interesting because here, this is why we don't use 3. We're not going to do 3 because the question is not 3. Does that make sense? So when we look, it's 4 plus 2 plus 2. It's not 4 plus 3. It's 4 plus 2. So we know that the pair of 2 is 3. To balance it out, this is how we do it. So the order is top to bottom if you have. Yes, it will always be from top to bottom. When we add, we're always going from top to bottom. We don't go from bottom to top. The numbers go down, you add it. 5 numbers go down, you add. Yes, exactly. So if I did 4, 3, 7, 8, 9, we start from here. Then we do this one. then we do this one, then we do this one, and then we do that one. Yes, yes, we go from top to bottom. That's how we add. That's how we add. You're absolutely right. Okay, does that make sense? Good. Okay. Whew, that was a lot of water I drank. How are we doing? So we added, we subtract. Okay, and then now we're going to subtract. So now we're going to start subtracting. Okay. Teach, do you have any more questions? Marvin, how are we doing? We're okay? Okay. So what we're going to do is we're going to subtract the 5. When we subtract the 5, we're just going to go through it. This is a little review how to make a 5. Remember, we're going to do 1 plus 4 is equal to 5. And this is what we're going to do. This is to help you color it in. So you can color in the 1 and you'll notice that there's four flowers that is not colored. So when we look, we're going to review how many flowers are in the pot. There's 5 flowers in the pot. So what are we going to do? We're going to draw a rectangle around, what number is this? This is 3. So we're going to draw a number. We're going to draw a rectangle around 3 flowers. So if I draw a rectangle around 3 flowers, then how many are not circled, right? So it's 3 and 2. So this is just to review about how to make a 5. Now we're going into how to minus a 5. Why are we going to minus a 5? Here's the question. If I have 8 and I want to take away 4, if I have 8, I want to take away the 4. Can I take away the 4? No, I only have 3 beads to take away the 4. So what do? I now know I could substitute. I want to minus the 5 plus the 1. So I'm going to minus the 5, I'm going to plus the 1. So my final answer is 4. We can do it again here. So this is a little spinning activity where we use a paper clip and then we do 16. So we have 16 and then minus 4. When we minus the 4, what are we going to do? Minus the 4 equals to minus the 5 plus the 1. So we're going to minus the 5, right? We're going to take away the 5 and we're going to add the 1. How are we doing? We're all right? So what we're doing is we're understanding, if we notice if we added the 4, now what we're going to do is we're going to minus the 4. And you'll see that there's a pattern. If I have 7 and I take away 4, I'm going to minus the 5 plus the 1. If you notice, thank you so much for the hearts. If you notice, I'm taking away. When I add, it's the same number pattern. If I take away and I add, it's the same number pattern. Make sense? So we add or we take away. We add, we take away. We add, we take away. What are you going to take away? So my final answer is 3. We can do it again with 6. When we do 6, we want to take away the 4. To take away the 4, minus the 5 plus the 1. And my final answer is 2. And we can do it again. If I have 5 and I want to minus the 4, I'm going to minus the 5 plus the 1. And my final answer is 1. And we could do it again with the 3. So when we have 3, that is our formula. We start with minus 3 minus 2 equals minus 5. When we look, we want to minus the 5 plus the 2. Here's my question. I'm going to have 7. I want to minus a 3. There's not enough beads to minus the 3. There's only 2 beads to minus, but I can utilize the 5. I'm going to minus the 5 plus the 2. So what did I just do? I substituted. Minus the 5 plus the 2 is equal to minus the 3. So my final answer is 4. And we could do it again. So if I have 26, right? If I have 26, and I want to minus the 3, remember how to minus the 3? Put it in the chat how to minus the 3. Do you remember how to minus the 3? Yes, thank you. Yes, thank you. Minus the 3 is equal to minus the 5 plus the 2. So I'm going to minus the 5. I'm going to add the 2. So sorry. I'm going to minus the 5 plus the 2. My final answer is 23. Because we're doing 26 minus 3. Minus 3 is minus the 5 plus the 2. So my final answer is 23. Okay? How are we doing? We're all right? And then we do it again. Minus 2. The question is 6. Excuse me. The question is 6. Okay, that was my second yawn. I am going to end this live pretty soon. Does anybody have any questions before I head out? I'm going to do the last question. We have minus 2 is equal to minus the 5 plus the 3. So we have 6 minus 2. Minus 2. Can you minus the 2? Minus 2 is minus the 5 plus the 3. My final answer is 4. Hello, Sincere. All right. Let me find my book. Let me find paper. Paper. I don't know where my papers are. Hold on. Hold, please. Excuse me. Yeah. Now I know I'm getting a little tired because that was my third yawn. All right. Thank you, Sincere. Welcome back. It's been a while. Let's do 766 plus 371. Easy! Let's take it slow. Right? I got my TikTok shop in front of me right now. Awesome! So we have 766. Right? And then we're going to add 3. Is there enough to add the 3? Oh. I need this. Excuse me. All right. Let's do it. We're going to add the 3. Is there enough to add the 3? Right? I need to add the 3 here. Is there enough to add the 3? Yes or no? No. Is there a 5 that I can add? Yes or no? No. Then what do? I go here. Can add the 3 plus the 10 minus the 7. So I'm going to plus the 10 minus the 7. That's my 3. Does that make sense? My next number is 7. Start it over. Is there enough to add the 7? No. Is there enough to, you can't do 7 here, right? There's no 7. So we go to, so is there, okay, so then 7 is equal to plus the 10 minus 3. Plus the 10 minus the 3. Plus the 10. We're going to add the 10. We got to start. Can you minus the 3? Can you minus the 3? Whoa, nuts. Let's start it over. 7, 7, 6, 6, 3, 10. Okay, can you minus the 3? No, we got to come down here. Can you minus the 5? Yes. Minus the 5 is, I'm sorry, minus 3 is minus the 5 plus the 2. Did that make sense? That was a 2-step equation. Okay. Can I add 1? Our final question is 1, right? Oh, sorry. Can we add the 1? Yes, add the 1. So my final answer is 1,137. Did that make sense? So this right here is our 2-step. Thank you. I got to brush up on the 2-step. Yeah. Yeah, that was a specific 2-step. So we had the 3, right? 3 is equal to plus the 10 minus 7. We did that. So we do it again. So 7, 6, 6. So we did minus the 10 plus the 3, minus the 10 plus the 7. Then here we got to do 7. 7 is equal to plus the 10 minus 3. So I'm going to plus the 10. And then if you look, I don't have any more beats to minus the 3. Minus the 3 is what? Minus the 3 is equal to minus the 5 plus the 2. Minus the 5 plus the 2. And then plus 1. And that's the answer. That was a good question. Thank you, Sincere. All right. So, other than felony, how are we doing? We all right? I'm going to end the live. Yeah, not a problem. You know what? Let me know if you have any more questions, Sincere, about arithmetic. Yeah. And we can take it slow, right? We can take it slow because that's a good question. I just missed the live. Next live, 2 questions. Next live, you know what? 8 o'clock. 8 o'clock Pacific Standard Time. I'm going to try to be more regular. Right now, it's going to be 8 o'clock Pacific Standard Time. 8 o'clock PST. Yeah. I downloaded a worksheet. That's where I got it. Oh, yeah. When is a good age to start? I'm trying to start the kids young, so I have activities, and I'm hoping that we could do 3, 4, and 5, and then they start learning how to read the beads. After they learn how to read the beads, then they go into adding and subtracting. You could start as young as 3. I've had students, and they stay on number recognition for about a year. So if you want to stay with it, or depending on how astute your child is or your student is, you can move them into adding and subtracting, moving the beads. But you could start it as early as 3. You could start at 4. There's not a problem with that either. That's as young. You could go you could go later, like there's 7, 8, and 9. You could do it, but then then there might be there's a little bit of friction because they already know how to do certain things, and they are just going to be able to because the way we teach the kids is, how do you make a 5? How do you make a 5? How do you make an 8? So the problem with that is you're going to have to kind of change their minds a little bit. So and that was the one thing is like when they're older, 7, 8, and 9 is a little bit, as long as they don't have attitude and they're okay with it. So I had a 5-year-old that was really good in math, but he didn't understand why we're using the abacus. And so it took a little bit for him to realize if he just did it through the abacus, then we could start, progressing further and faster. But it did take a while for him to understand to use the abacus because he would just have to because he knows how to do it in his head. And that's the one thing when the kids are older is that you'd have to do that. So math is hard. Math can be hard. Abacus makes it a little bit easier. So, okay, so that was the 2 questions. Was any other questions? Any more questions? Thank you, Michaela. That was fun. Yeah, I hope it was fun. Download, yeah. Let's see. Okay, if there's no other questions, sorry, it's been a while for me. So if there's no other burning questions, I am going to sign off, and I will see you guys all in my next live. How are we doing? We're all right? Sincerely, let me know if you have any more questions. Yeah, thank you, Anna. No, thank you for joining. Thank you for joining, Anna. I hope this was helpful. I hope it was interesting enough to be understanding. But if you have any more questions, let me know. All right. Anything else? Okay, cool. Thank you guys. Thank you everybody for joining, and I will see you. Okay, good. Okay, good, Sincere. I'm so happy you joined. I'm so happy you dropped in. But yeah, my next one will be 8 Pacific. I think that would be it. 8 Pacific. Tonight. Tonight? Yes, because tonight is Wednesday. So thank you guys. Thank you. Thank you for joining. I will see you guys all in my next live. Bye. I was about to ask about the two-step. If I can't, you then. What? What about the two-step? What about the two-step? Ask me. Ask me now. So this is why the framework is very helpful, right? The question is you take one number and you can see if you can use it, right? So if you can use it, then do it. If you can't, then you got to go through this process over and over again. So now we're talking about procedurals. Sorry. What about the two-step? No, ask me. Ask me what the two-step is. Now I'm just waiting. I'll ask you about the two-step. What about it? Okay. I guess you left. All right. Oh, that's interesting. Pin comment. I can pin comments. That's crazy. Can I do it here? Oh, I can do it here. Oh, well, huh. Interesting. Thank you. I don't have any right now. Oh, I see. I see. Okay, yeah. Yeah, not a problem. Okay, so I'll see you in my next live if you have any more. Okay, I'll talk to you later. Bye. Oh, interesting. Pinned. Okay, bye. And now.